problems are going to look a lot like the problems that you have been doing already, except for they are going to have inequality signs. And for a lot of other things that you have done, when you had the inequality signs, the work ended up being more or less the same. You know, like if you were solving 2x plus 7 equals 10 versus 2x plus 7 is greater than 10, you didn't change much about how you did the work, right? You pretty much did the same thing. If you divide by negative, you got to flip the inequality sign. But otherwise, it pretty much is the same as solving equations. For these problems, they're going to be quite a bit different because there are some things that we did when we were solving equations that you cannot do when you're solving inequalities. And the big thing is you cannot get rid of your denominator. So whenever we solve the equations, we would get common denominators and then we would just mark them out, right? And then we would finish solving. Because all we care about there is when we have something that's equal to that value. With less than or greater than, that denominator affects the sign of your answer, whether or not it's positive or negative. So the denominator cannot be marked out in these. Okay, so what we're going to do is going to be quite a bit different than solving for equations. So the first thing that we want to do, first step, we're going to put our steps over here, is we want to move everything to the left side so that the inequality is less than or greater than, or less than or equal to or greater than or equal to 0. So on that right-hand side, you want to have a 0. Today, every problem we look at is already going to have that happen for us. So we're not going to do that step today because all of the problems we're going to look at are already going to have everything moved to one side. Tomorrow, we will look at problems where that's not the case and we've got to move stuff to one side. The second thing that you are going to do, which, let me flip through, I don't think we are doing today either. Yeah, we're not doing this today either. So this is tomorrow, but I'm still going to put it up here because I want you to have the steps that work for every problem. So you will combine fractions if necessary. And what I mean by that is like if you have 1 over x plus 2 plus 3x over x minus 1, I mean that you would get common denominators. This is the x minus 1. And this would be x plus 2. And so if we put that together, we would get x minus 1 plus 3x squared plus 6x all over x minus 1, x plus 2. So get common denominator. You need to have one fraction on that left-hand side. And we'll look at this more tomorrow because we're going to do some problems where we have to do that tomorrow. Today, we are not going to have to do that because I'm only giving you problems where everything is already on one side and you have already have those combined. Okay? So 3 is where we're picking up today. Find all values that will make the numerator or denominator equal to 0. So we are looking for anything that will give us a 0 in the numerator or the denominator. So we're just taking our numerator, which is x minus 5 here. We're setting that equal to 0. We will get x equals 5. In the denominator, we will have 4 minus x. We want to see where that would equal 0. So if we add that x to both sides, we get 4 equals x. So these numbers here, in calculus, so we don't do this in calculus, but we do something similar to calculus. In calculus, we would call these our critical points. They're places where we might switch from positive to negative or negative to positive. Because if we want to go from a negative number to a positive number, what number do we have to cross first? 0, right? That's where we switch from negative to positive. And so what we're going to be looking at here, we are looking for where this expression is greater than 0. And all numbers that are greater than 0 are positive numbers. So for all of these, we want this to have a 0 on the right-hand side, because that means that we can look for where this expression is positive or where this expression is negative, which is a lot easier than looking for where this is greater than 1 or where this is less than -7 or something like that. So we always want to have a 0 over here. And what we really care about is we want to know what would make this stuff positive, right? So what we are going to do next, step 4, put these numbers on a number line. Make sure they're in order. So, got me a number line. I'm going to put my 4 first, and then my 5. And so what happens here is at 4 or at 5, I would get values that would equal 0, either in that numerator or that denominator. So in between these points, what I should see is that I should get the same sign for the whole section. Like if I pick any number between 4 and 5, which there's no whole numbers, but there's plenty of numbers there, right? 4.1, 4.2, 4.3, 4.7821, all of those are in between 4 and 5. Any number I pick in that section should give me the same sign. Because in order for signs to change, you would have to cross a point where it gives you 0. So we are going to then pick a number from each region and test to see if it is, or if, when I say it is a bad word to use in math. You really shouldn't use it. If the expression would be positive or negative for that value. All right, so you have 3 regions here on your number line. You have this section, which is all numbers less than 4. You have this section, which is all numbers between 4 and 5. And you have this section, which is all numbers above 5. And you're going to test one number from each section. It does not matter what number you pick. So numbers less than 4. Let's see. Lily, pick me a number that is less than 4. Okay, so if we pick 3, we're going to pick 3. It falls right here. And we are just going to plug it into our expression. So 3 minus 5 over 4 minus 3. That is going to give us negative 2 over positive 1, which is a negative 2. All we care about is whether or not that's negative or positive. Not really its value, just whether it's negative or positive. Is it negative or positive? There. We got a negative for that. So negative 2 divided by positive 1 is going to give us a negative 2. So in this section, we're getting a negative answer. And what's going to happen, because we picked the points where we get 0 in that numerator or denominator, anything we pick in that section is going to give us a negative value. So just to you don't have to check anymore, but to prove it to you, if I did 0 minus 5 over 4 minus 0, it would give me negative 5 over 4. Still negative, right? And I could go on picking numbers, but if you've got the correct critical points, the 4 and the 5, the things that make your numerator and denominator 0, then everything in the region below 4 should have the same sign. Okay? So now we're going to move up here to between 4 and 5. We're going to pick a number to plug in. This one's not quite as friendly because there are no whole numbers between 4 and 5. So Monica, pick me a number to plug in here between 4 and 5. 4.5 is also probably what I would choose as well. You're going to plug it in to your inequality here. So 4.5 minus 5 over 4 minus 4.5. And so when you do this, you will get negative 0.5 divided by negative 0.5. Negative divided by negative gives you a positive. In this case, positive 1, but we really don't care what the value is. We just need to know whether or not it is positive or negative. So if you had picked like 4.1 and you were getting something, difficult to know the actual value, it doesn't matter, just as long as it's, if it's positive or negative. Okay, so we got one more section to check. We're going to pick a number above 5. So Lee, pick me a number to test. All right, so 6 right here. So you would do 6 minus 5 over 4 minus 6. And so for this, you're going to get a positive 1 over a negative 2. Again, we only care about whether or not that is positive or negative. What are we going to get there? A negative. So we would have a negative in this section. All right, and then the last thing that we're going to do, we're going to add it to our steps here, step 6, is we are going to choose the regions that make the inequality true. So, for this problem, I had greater than 0. So, positive numbers make this inequality true. So, if I look at my number line here, the ones that work are the ones where you get a positive. So, that's this whole region right here. And we would say that our answer for this is going to be from 4 to 5. Notice that I used parentheses instead of brackets. That is because my original problem was a greater than problem. I don't want to know whether or equal to 0, right? So if your original problem is less than or greater than, you're going to use parentheses on everything that you would have as your answer. Now, let's say that this problem was a little bit different. Let's say it was less than 0. Then we would say negative infinity to 4 and 5 to infinity. You would choose the negative sections of the graph. Does that make sense? So any number between 4 and 5 should give you a positive value, but anything outside of that is going to give you a negative value, which is not going to be part of your solution. Okay, questions? So solving these is quite a bit different. You got to test these regions. You cannot do it just by like marking out denominators and finishing solving for that. It won't give you the correct answers on these. All right, so here's another one. All right, we got x minus 3 times x plus 2 over x minus 4 squared, and we want to know where this is less than or equal to 0. So less than or equal to 0, what kind of answers are we going to be looking at when we get our number line? We're looking for negatives. Or 0. So keep that in mind. What that's going to mean is we might have some brackets on our answers for that. But otherwise, it doesn't change a lot about what we do. So we want to know everything that would make the numerator or the denominator 0. So in the numerator, that would be x equals 3. It would be x equals negative 2. In the denominator, it's going to be x equals 4. Okay, but you're setting all those equal to 0. Everybody okay with me just skipping straight to the answers on those? This is already factored for us, so we can do that. We're going to see on the next ones we'll have to factor. So we're going to put these numbers on a number line. And so we've got negative 2, 3, and 4. Make sure those are in order, because if you put them on the line out of order, it will mess your answer up. Okay, now I'm going to show you a tool that you can use if you would like, but you do not have to. Okay, so I like to make a chart for this, and I think it makes it a lot quicker to answer this problem. You may not care for it, and you may use the exact same way that we did just the last time. But whenever I have more pieces here, plugging numbers in starts to take a little bit longer. All right, so like if I plug in negative 3, I'd plug in negative 3 to all of these, and it takes a little bit longer to plug in because there's so many places to plug it in. So this is an option if you like the chart. So what I'm going to do is I'm going to take all of these, x minus 3, all the factors, x plus 2, and x minus 4 squared, just basically all the factors here, and I'm going to put them on a chart. And then I'm going to leave myself space right here for the actual answer. And I'm going to split this here at all of those critical points. And so what I'm going to do on the chart is I'm going to look at each piece individually to see if it would be positive or negative. So when I have x minus 3, I'm thinking about taking numbers and plugging in just the x minus 3. Not the whole thing, just the x minus 3. So if I plug in negative 3, will I get a positive or a negative? Negative 3 minus 3, that would give me a negative right there, right? Between negative 2 and 3, I might want to pick 0. I'm going to write these numbers down here. So like picking negative 3 right here, I'm picking 0 here. It's not the only number I could pick. I could use 1, I could use negative 1, I could use 2. There. So if I plug in 0, 0 minus 3, still negative. if I pick a number like here, 3.5, if I plug in 3.5, 3.5 minus 3 is going to be positive. And then a number bigger than 4, maybe like 5, I would get a positive there. What you're going to see for these is that you should only switch signs one time, and it should happen at that place, at the 0 that goes with this. So if you do more of these problems, you would be able to plug these in a lot quicker rather than doing the whole thing. So if I think about 2, if I plug in a number like -3, I will get a negative here. And then if I plug in a number here, like 0, 0 plus 2 is positive. And then anything bigger than that's also going to be positive, right? So I just go ahead and put positives right there. So you can kind of think about it a little bit quicker. What about that x minus 4 squared? What are you going to get for it? So when you square something, what do you know about the sign of what you're going to get? It's going to be positive every time, right? Because no matter what I get inside of the parentheses, positive or negative, when I square it, it's going to be positive. So I could just go ahead and do positives all across that line right there without really having to think about the points at all for that. So if we think about what we're doing here, with our chart, I've got, like, in this segment right here for -3, what I'm going to end up with is a negative number times a negative number over a positive number. Okay? What's the negative on times negative on top going to give me? A positive. Positive over positive will be positive overall, right? For my green I'm going to use green for this next section. Plugging in 0, I would have a negative times a positive over a positive. That will give me a negative over a positive, which is negative. So I get a negative in that section. For the last 2 sections, everything's positive for both of those. So for those last 2 sections, you've got positive times positive over positive, which clearly has to be positive, right? So you'll get a positive here. You'll also get a positive here. Okay. Now, a trick that makes this even quicker is if you have an odd number of negatives, your answer will be negative. And the opposite is also true. If you have an even number of negatives, your answer will be positive as well. So rather than doing what I've done down here, I could just say, oh, negative, negative, positive. There's 2 negatives. That means I'm going to get, that's an even number. I'll get a positive here. Here, I've only got 1 negative, so it's negative. Obviously, no negatives in either one of these, so that's positive for those. So I like using the chart because I think it helps me do these problems a lot faster because they can become kind of tedious plugging numbers in. But let me, if the chart is confusing you, I'm going to use it a couple more times, but let me go back. If you followed me on number 1 and on number 2, you're like, this doesn't make sense, Miss Hyatt. You don't have to do the chart. So if I want, I would still have to find these numbers. I would still make my number line. But if I wanted to do this without the chart, then I could just like pick a number, like I picked -3 right here, and I could plug it in. I could have -3 minus 3 times -3 plus 2 over -3 minus 4 squared. And I could work it out. I'll get -6 times -1 over -7 squared. This will give me +6 over +49, and I'd get a positive for that section. So you could do that. Then you could go on to the next one and plug in 0. So 0 minus 3, 0 plus 2, 0 minus 4 squared, and then work that out to see if you get a positive or a negative. So the chart is just a tool that might help you do it a little bit faster. You don't necessarily have to use it. And I spent a lot of time explaining it. I can use the chart really fast. And if you do more, you'll see that it can help you speed up on these, but it's not necessary. All right, so for example 3, I need to know what will make the numerator or denominator 0. This is going to be easier to do if it is factored. So I'm going to factor the top into x minus 2, x plus 2. And I'm going to factor the bottom into x plus 5, x minus 2. Now, I need to give you a warning here. Do not cancel. Okay? I do have an x minus 2 on top and bottom. If it was an equation, it would be fine to cancel it. You don't want to cancel those because it can cause you to miss an answer for those. So you don't want to cancel your x minus 2s there. So do not cancel if they show up where they will cancel. So I am going to, like I did on the last problem, I'm going to look for the things that will give me 0 in top or 0 in bottom. So that is going to be x equals positive 2, x equals negative 2, x equals negative 5, and then this last one right here just gives me positive 2 again. You don't need to list it twice. So I am going to put these on a number line, -5, -2, positive 2. And then every factor over here needs to be listed on the left-hand side if you're going to use the chart. So you'll have x minus 2, x plus 2, x plus 5, and x minus 2. And then leave yourself a spot for the answer. You're going to mark off the sections on your chart. Notice that even though x, now down here for like my x minus 2, that gave me 2 twice. I only put it on the number line one time because it's at the same spot. But you do need to list the x plus 2's or x minus 2's both. So make sure you list them both. So if I pick numbers to plug in here, you know, like right here, maybe -6. -6 minus 2, it's going to give me a negative. If I pick something between -5 and -3, maybe like -4, -4 minus 2 still gives me a negative. If I pick something here like 0, 0 minus 2, still negative. Something bigger than 2, like 3, that will finally give me a positive for this. Because this factor right here is the same, I can just copy that line right there. I don't have to think about that one. It's going to be the same. Then, if I'm doing the same thing for x plus 2, if you kind of think about this, anything below -2, -4 or -6 or even -5 for that matter, is going to give you a negative. But then when I have at -2, I'll get 0. Anything above that, like 1 or 2 or 0 or 5, I will get a positive for that. And then, if I look at this one, at negative 5 is when this is going to equal 0. So if I plug in any numbers below negative 5 in, like negative 6, I will get a negative number. But anything above negative 5, like negative 4 or 0 or 3, or negative 2 or 2 for that matter, I get positives. So hopefully you'll get to where you can fill these in a little bit more quickly than if you plugged into the original. Okay, any questions so far on setting up that part of the chart? Now, I just want to look at my chart. In this column right here, I have 4 negatives. That's an even number. That's going to give me a positive. Right here, I have 3 negatives. That's an odd number. That's going to give me a negative. Here, I have 2 negatives. That's even. That gives me a positive. And obviously, the last one is all positives there. Okay, so for this problem, the reason that we always make sure everything is on one side, which we haven't had to worry about for these problems, is because we want this to be either greater than or less than 0. Because greater than 0 would be positive, less than 0 would be negative. This is greater than 0, so we are looking for answers that are positive. So whenever we get this, any region that is positive is going to be part of our answer. Okay? So for this, our answer would be negative infinity to negative 6, negative 2 to 2, and 2 to infinity. Oh, I think I messed something up on the last problem. I got to go back. Let's get this first, though. It's very minor, but I think it makes a difference. Oh, I'm sorry. Yes, I was looking at that wrong. I was looking at the number that I plugged in. Thank you. Negative 5. These two are right next to each other. Why would we not include 2? It is an excluded value is one reason, and the other is this is a greater than sign. So even if it wasn't an excluded value, you would get 0 at that point. So we got to use parentheses. We wouldn't put those two together for that. When in doubt, it's best just to separate them all out. There are some cases where those two could be put together. You'd have to have an or equal to sign there, though, for that to happen. If you have a less than or a greater than sign, you need to list every section separately for certain. Okay, questions? All right, I said I think I messed something up on 2. I didn't answer the question on 2. Is what I messed up. All right, so let's go back. I didn't even answer the question. I got caught up in showing you this other way, and I didn't even answer the question. Which sections are our answer for number 2? Negatives, right? So we're looking at this section. Now, so because we have an or equal to this time, we want to use brackets if we can. All right, so my answer would be negative 2 to 3 with brackets because it can equal 0. But you want to check excluded values on this. So what is the excluded value for this expression? 4. You cannot have a 4. So this is okay because I can include negative 2 and 3 because neither one of those are excluded values. So this is going to be my answer. If it were to include 4, you would have to change whatever's with the 4 to a parentheses because you can't actually have 4. Hopefully that's going to happen on the last problem so you guys see what that looks like. Okay, questions? All right, sorry, I forgot to answer number 2. There we go. All right, now we're ready for number 4. Okay. I might change. Let's do our chart, and I may change this to a less than at the end just so we see something that happens. So I reserve the right to change the original problem here just because I want you to see something special that happens. So it's always best to go ahead and factor these. So x plus 3, x plus 1 is how that numerator will factor. Denominator is going to be x plus 3, x minus 3. I'm pretty sure I want it to be less than or equal to 0. I may change my mind again when we get to the end. Let's do less than or equal to 0. Alright, so we need our points to put on our number line. They're going to be x equals negative 3, x equals negative 1, and x equals positive 3. So if we use the chart on our number line, we'll have negative 3, negative 1, and positive 3. Here, we're going to have x plus 3, x plus 1, x plus 3, x minus 3, and then room for our answer there. So for our x plus 3, negative 3 would give us a 0 on that one. Anything below negative 3 is going to give us a negative. Anything above negative 3 will give me a positive. Okay, do you guys see how I'm doing that quickly? Okay, so rather than plugging in a number for every single spot, which you can do, I know that negative 3 would be the number that would give me 0 here. So that's going to be like the point that I switch from negative to positive. So then if I just think, oh, well, something less than negative 3, like negative 4, that's going to give me a negative. Anything bigger than that would have to give me a positive. So you're just, unless you have something weird like an x squared plus 5 or something like that, it should only switch one time for that expression. I can also go down here and copy that one to that third line because it's the same. It's the same there. For x plus 1, that is going to equal 0 at negative 1, so that's going to be sort of my splitting off negative positive point. Anything below negative 1, like negative 2, is going to give me a negative. So over here I will get negatives. And then up here, I will get positives. And then for the last one, 3 would give me 0 for that. So that's the place I'm going to switch from negative to positive or vice versa. Anything below 3, like 0 maybe, is going to be a negative. So everything over here on the left-hand side of 3 is going to be negative. Everything on the right-hand side is going to be positive. No. Change it back to the way it was. It was fine. I should have just waited to the end. Okay, so we're going to have even number here. We'll get a positive for our answer. Let me use a different color so that answer line stands out. Here we also get a positive because we just have 2. We'll get a negative right here and a positive for that last one. So, which regions are going to be our answer? The positive ones or the negative ones? Positives, because we are looking for where this is greater than or equal to 0, so positive. Okay, so because we have the or equal to here, we want to use brackets. But if you've got pen, you might want to hold off. We're going to do some erasing. So obviously I don't use a bracket with infinity. So negative infinity up to -3, I'll use a bracket there. And then from -1 to 3, and from 3, oh, I'm sorry, I don't know why I did that, -1 to 3. That one's negative. Well, back up. -3 to -1, that section's positive. Skip -1 to 3, that is not part of our answer. And then 3 to infinity. You cannot, and here is why. Okay? So what I have written down, I need to go back and think about excluded values. Okay? So if you have a less than or greater than sign, you don't even have to think about this. All of them should be parentheses. So this is only going to happen whenever you have an or equal to sign. But excluded values from this denominator would be +3 and -3, which means even though I have an or equal to sign, I cannot use -3 or +3 because it gives me a 0 in the denominator that is undefined, and undefined is neither positive nor negative, so you can't include it in your answer. So what I'm going to have to do is take my answer and go back at anything with -3. I need to change this so it is a parentheses. So that would be both of these right here need to be a parentheses. They cannot be included because they are excluded values. And then I need to go over here and change that 3 also to a parentheses. It ends up that the -1 is the only one that it can actually equal. So that's your only bracket in the problem. And so now, Gabby, you're skipping over that -3 so you wouldn't include it. Now, it is possible, there is a chance that you do this problem. I don't think this is going to happen very often ever, but that you do this problem and that bracket is still there. So the -3 is included. And if that happens, it is okay to combine that together to make it -infinity to -1. But in this case, that ends up being an excluded value, so you can't do that. You only have to worry about this if you have an or equal to sign. If it is a less than or greater than sign, just parentheses with everything. Don't even think about it because you don't include those values anyway. Okay, questions? All right. Here is one more that we're going to do. How do I factor the top? We can pull out a greatest common factor. So you have to take the x out. You can also take the 4 with it if you would like. I probably would, but it doesn't matter. You can take the 4 or leave the 4. It doesn't matter. And then you'll get 2x plus 1 in that numerator. The denominator you can leave as is. It is x minus 4 times x minus 4 times x minus 4. You can write it 3 times if you want, but I would just leave it like it is. Let's put an or equal to sign on this one just so we can, it makes it harder whenever there's an or equal to sign. So let's do it just so you've seen one more of those. If it doesn't have an or equal to sign, parentheses on all of your answers. By putting the or equal to sign there, we got to think about it a little bit. So, what are our values for this? Lennon, what would be one of them? 4 is one of them. Gabby, give me another one. Yes, 4x would equal 0, which would be 0. So 0 is going to be one of them. And we've got one more. Liam, what's the other one going to be? Okay, so right here, the 4 came from your x minus 4. The 0 comes from your 4x. The 2x plus 1, you're going to do 2x plus 1 equals 0, and you're going to solve that. So 2x will equal negative 1. X will be negative 1/2. So whenever it's just whole numbers, we don't have to think about it as much, but when you got that 2x plus 1, you got to think about it a little bit more. So we are still going to do a chart for this. We got negative 1/2. We got 0. We've got 4. We are going to list our factors over here on this side. We got 4x. We got 2x plus 1. And then we got x minus 4 to the third power. And then leave yourself a spot for your answer. Okay, if we start checking points, 4x is going to equal 0 at 0. If we plugged in a negative number, it's going to give us negatives. If we plug in a positive number, it'll give us positives. The 2x plus 1 is going to equal 0 at negative 1/2. If we plug in a number below negative 1/2, like maybe negative 1, 2 times negative 1 plus 1 would give us a negative here. And so then it'll equal 0 right here. Anything above this is going to give you a positive. Okay. This last one seems a little bit like the one where we had like the x plus something squared. But this time it's raised to the third power. Does raising something to the third power guarantee it's going to be positive? It does not. So if you get a negative and you raise it to the third power, it'll still be negative. If you get a positive and raise it to the third power, it'll still be positive. So really the third power doesn't change stuff very much. We're really mostly looking at this 4. This will equal 0 at 4. If I plug in something below 4, I'm going to have a negative number raised to the third power, still going to be negative. So I'll get negatives here all the way up to 4. And then number bigger than 4, like 5, is going to be a positive number inside of the parentheses. Positive number cubed is going to be positive. So if we go through to do our answer, odd number here, we got 3 negatives, so that'll be negative. Even, that'll be positive. Odd, negative, even, positive. Now, if we're thinking about our answer, is it going to be the positives or the negatives here? Negatives. So we are looking at this region and this region as our answer. If you want to do excluded values first, you could. What's the excluded values? X equals 4, because 4 would give you a 0 in the denominator, right? You're just looking at the denominator. So if you want, you could put your big X right there on 4. You could do this from the very beginning of the problem if you wanted to. So you can't have 4. So whenever we answer this question, because it is less than or equal to, we want to use brackets if we can. So we would have negative infinity up to negative 1/2. We can use a bracket with negative 1/2. It is not an excluded value. Then we've got 0. It's okay to use a bracket there. But at 4, 4 is an excluded value, so I've got to use parentheses. And this would be our answer. Okay, questions? All right, these problems take a little while to do.